Have you ever stared up at the night sky and wondered, does the universe ever end? Today we're diving deep into one of the greatest mysteries of all time. Is the universe infinite? As far as we can tell, the universe seems to stretch endlessly. But could it truly be infinite? To get to the bottom of this cosmic question, let's rewind the clock back to 13.8 billion years ago. Picture this. The universe began with a colossal event we call the Hot Big Bang. It was an unimaginably hot and dense state, filled with matter, antimatter, and radiation, expanding and cooling over time. Fast forward billions of years, and our observable universe has expanded to an astounding 46 billion light years in radius. That's the distance to the furthest light we can see, arriving at our eyes today. But remember, that's just what we can observe. What lies beyond that? Can we determine if the universe is finite or infinite based on what we know? Well, let's dig into the evidence. When we look at distant galaxies, we're also looking back in time. The light from the nearest galaxy, which is 2.5 million light years away, shows us what it looked like 2.5 million years ago. The farther we look, the further back in time we see. Today's universe is cold and clumpy, always expanding and gravitating. But as we peer into greater distances, the universe appears less cold, less clumpy, and more uniform. Early on, it was much hotter, too. We measure the universe's temperature today by examining the cosmic microwave background, CMB, radiation. This leftover glow from the Big Bang tells us the universe is currently 2.725 K. It's amazing how well these observations fit the predictions from the Big Bang model. We also understand how this radiation changes. When the universe was half its size, photons from the Big Bang had double the energy. If we go back to when the universe was just 0.092% of its current size, it was 1089 times hotter than it is today, around 3000 K. At that time, the universe was a hot ionized plasma, even though it was almost perfectly uniform and tiny. To guess what lies beyond, we rely on physics. If space were positively curved like a 4D sphere, distant light rays would converge. If negatively curved like a 4D saddle, they'd diverge. But measurements indicate that the universe is spatially flat to a precision of 0.25%. Given this flatness, the unobservable universe must be at least 37 trillion light years in diameter. But it could be even bigger. Before the Big Bang, the universe went through cosmic inflation, expanding exponentially at a constant rate. Although inflation ended in our region, the overall universe might be far larger than what we can observe. There are still three big questions. 1. How big was the post-inflation region that sparked our hot Big Bang? 2. How long did inflation last? 3. What's the upper limit to the energy scale of inflation? Answering these could help us understand the true size of the universe. Whether it's finite or infinite, it's clear our universe is far grander than we can currently comprehend. Don't forget to hit that like button, smash subscribe for more jaw-dropping space updates, and join us as we embark on a cosmic journey like never before.